All right, so math one, we start off with equations. For now, we're just going to start with kind of some 7th grade stuff with the equations. All right, so before getting into too much, one of the things we got to do always with equations, or possibly always, is we might have to distribute. All right, so when we have parentheses, that's when we might have to distribute. So when we're distributing, what do we do? Multiply. So we're taking, what are we multiplying? Number on the outside, in this case the 8, and we're multiplying by what is on the inside. So we got 8 times 2g, in this case that's 16g. I got 8 times minus 9. We got to pay attention to our signs. So that's a minus 72. All right. This should not be anything crazy difficult, hopefully. Y'all go ahead and do those other ones. Give me number 2. Negative 65d minus 55. That was correct. How about number 3? Great. 4m plus 32 is correct. Okay. Any questions on those? Biggest thing is just paying attention to those signs, okay? When you distribute, if the signs are the same, you get a positive number. If the signs are different when you're multiplying, you got a negative number, okay? All right, so let's look at the next little part. Combining like terms. When you are looking to combine like terms, if they have variables, you can combine them. If they have the same variable, if they have different variables, you can't combine them. Or if one has a variable and the other does not, they can't be combined either. So in the case of number 6 here, I got a 13R and a 5R. I can combine those, and you pay attention to whatever signs they have. This has a plus in between, so I just add. That makes 18R. The 2N, that's got a different variable, can't be combined, got to keep it separate. Everybody kind of follow? And that's basically 6th grade math. So, all right, y'all do 7 and 8 there. No, I skipped over some numbering stuff, but Didn't see the need for all those problems. Number 7. Lacey?
13K plus 60.
No? Yeah, we got negative 13K plus 16. Since we got a minus K and a minus 12K, we combine them because the signs are the same. They're both minuses, but we got to keep that sign on those. Number 8 here. Lenny?
17M plus 25G.
Nope. Kari?
17M minus.
Ford?
Negative 3M plus 25G.
Negative 3M plus 25G. All right, so signs are important again with this, okay? When you combine like terms, you're following your rules for addition and subtraction. So when you have like number 7 here, when the signs are the same, you add and you keep the sign. When you have like number 8 here, when the signs are different, you subtract and you use the sign of the bigger number. So we got different signs. We got positive 7, we got a negative 10. That makes our 3 going to be a negative 3M there. The other way you can kind of look at that is which one we got more of. We got more of the negatives, right? So that means we're going to have more of a negative when we combine them as well. So that gives us that negative 3M. Okay? Any questions there? So that's kind of review stuff from, actually a lot of that was 6th grade stuff. Distributing you did in 6th grade. Combined like terms you did some in 6th grade. All right, so equations. We have one-step equations. When we solve a one-step equation, what we want to do is we are going to isolate the variable by using inverse operations. You won't get the variable by itself by doing the opposite. So you're trying to get the variable by itself. So a one-step equation is where you'd have x plus 7 equals 12. The one-step equations are the ones where you maybe don't necessarily have to do the math to solve them, but doing those steps kind of help you learn the process a little bit. So by doing an inverse operation, inverse is the opposite, so the opposite addition, you would subtract. You subtract 7 from each side, so the 7's cancel there. We got x equals 5. Everybody kind of follow? Any questions on that part? All right, two-step equations then. With two-step equations, so those are the ones where you get maybe like 3x plus 4 Let's go with equals 13. Something that looks like that. And yeah, possibly more complicated looking. First, use addition or subtraction to remove the constant. So in this case, the constant is the 4. You remove it by doing the opposite, just like we would have with the one-step equation. If you do something on one side, you do the same thing to the other. So I got 3x equals 9. Next, we use multiplication or division, whichever one's the opposite, to remove the coefficient. And if you're multiplying, or if you're dividing by a fraction, what that ends up doing is multiplying by a reciprocal. Keep, change, flip on a fraction. Reciprocal is what you call the flip fraction. All right, everybody with me on that? All right, so these are all one-step equations here. Solve them by doing opposite. So, number 1 there. That's a division problem. We got x divided by 1.5 equals 16. So the opposite, what we do, we multiply by 1.5, right? So if I multiply both sides by 1.5, what it does is it cancels out those 1.5s. That's what we want. So we're left with 16 times 1.5. If you ever need to check it, you can just plug it back into the first equation. I could do 24 divided by 1.5 if I needed to. I'm not going to do that one. Number 3 here. I'm going to skip to that one. It's got a fraction. That's multiplication, right? I got 6/7 times e equals 12. I would divide by the fraction, right? Right before this, we said dividing by a fraction is the same as multiplying by the reciprocal. So multiplying by the reciprocal is the flipped fraction. So when we do that, what that's doing is it's canceling out the fraction on the left side, which is what we want. And then there's a couple different ways you can look at that and do that. You can multiply straight across your tops and straight across your denominators. So 12 times 7 will give me 84. 1 times 6 on the denominator gives me 6. And then I can just do my division there to simplify that. 84 divided by 6. Yeah, gives gives me 14. Any questions on those? Yeah, I'm going to skip 2 and 4. They're just addition and subtraction. Anybody need to see those? Just do the opposite. All right, multi-step equations. They even left off a step, I think. So I'm going to add it up here. First step, if you have parentheses, you want to distribute. Then, if possible, that's when you combine like terms. But if there's parentheses, you're going to distribute first. Then you're going to go ahead, try to isolate the variable by doing opposite to solve the equation. So now these are the ones that get, a couple more steps to them, possibly. A little more complicated looking. Not necessarily horrible looking, just a little more. All right, so A here. I combine like terms. My like terms are the 8x and the minus 2x. The minus 28 and the minus 10 are not like terms because they're on opposite sides of the equal sign. Okay? For them to be like terms, they have to be on the same side of the equal sign. Everybody clear on that? So 8x minus 2x is 6x. I still have minus 28 on the left side, and that equals minus 10. Everybody good with that step? Anybody got any questions on that step? All right, so then I solve. I get rid of the constant, the addition or subtraction, by doing opposite. So I add, in this case, 28 to each side. My 28s cancel out there. I got negative 10, positive 28. Signs are different, so I subtract, use the sign of the bigger number. So I got 6x equals 18. And then I divide. 18 divided by 6 gives me 3. Everybody go with that? Not so bad, right? All right, y'all do G. Again, I kind of switched up the order a little bit on this. Mason, what you got?
I was gonna ask.
You got a question? Ford, you got?
X equals 23.
All right, so we combine our like terms. In this case, I've got 7x, a minus 10x, and a plus 2x. I would just kind of work my way from left to right. Okay? So 7 minus 10 is negative 3. Negative 3 plus 2 is going to give me negative 1x. Everybody with me on that part? I've got plus 18 equals negative 5. I can't combine the 18 and the negative 5 because they're on opposite sides of the equal sign, okay? Now to solve, I got to move the 18 over by doing opposite. So I go minus 18 to each side. Cancels out there. On the right side, signs are the same. When the signs are the same, we add and we keep the sign. So that makes negative 23. So we got negative 1. And then we're dividing. Negative divided by negative makes that a positive. So that's how we get back to a positive 23. Okay? When we get here, we are going to distribute first. So step 1. Whoops, didn't mean to do that. Then we combine like terms, and then we just solve. All right, so we distribute. I'm going to move that negative 4 to both parts, just what's inside the parentheses. So negative 4 times a negative 6x makes positive 24x. Got to pay attention to our signs. Negative times negative makes that a positive. Negative 4 times positive 1 or times the plus 1 makes that a minus 4. That minus 8 is not part of the parentheses, so we keep that as a minus 8. Equals 12. Now we combine our like terms. My like terms in this case, I got minus 4 minus 12, or minus 8, sorry. Skipping ahead to the answer. 24x minus 4 minus 8, signs the same, we add. That makes a minus 12. Still equals 12. Solve by doing opposite. So I add 12 to each side. Trying to get that variable by itself. I got it to 24x equals 24. I divide. I get it to x equals 1. Any questions on that one? So you distribute, combine like terms, solve the equation. The only thing you're going to have to do for sure every time is solve the equation. Sometimes you'll have to distribute, sometimes you'll have to combine like terms. All right, y'all do number 2. All right, who has an answer to number 2 there?
X equals 30. Or which?
X equals 20.
All right, so we distribute first. Oops. So I got the 4, I got 2x, I got minus 16 equals 44. I combine my like terms. I got 4, I got minus 16. That makes a minus 12. So I got 2x minus 12 equals 44. Solve by doing opposite. So I'm going to add 12. So I got 2x equals, that makes 56. We're going to divide. We divide by 2. That's where the 28 comes from. Any questions on that one? I think most of you at least get the process on this and get what you're supposed to do. It's just a matter of getting back into the practice of it kind of thing. Now, I think the initial microphone I was using was kind of dead, so video might be a little bit kind of messed up, so sorry about that.